My name is Stephanie Williams. XRD can tell you lots of things about a sample, and it's a very powerful technique because it's non-destructive. So there's this little thing called Bragg's Law, and essentially what it means is that if you have a crystal, you have long-range order. So you have atoms lined up the same way for very, very long periods in X, Y, and Z. So when an X-ray comes in and diffracts off of an atom, if the atoms are routinely spaced, you essentially will have X-rays diffracting on the same wave period as the other atoms. And what that does is it makes constructive interference versus deconstructive. So if you have two waves like this, you just get a bigger wave. But if you have like a wave like this and a wave like that, you get nothing, right? So the more atoms you have lined up in a row, the more the X-rays are lined up themselves, and you get what's called diffraction. You get a spot on your detector. And so what that means is that there are these planes of repeating atoms, and those reflections correspond to specific peaks in what we call 2 theta, which is essentially the inward angle and then the outward angle. And so based on those measurements, every crystalline material is going to have different diffraction peaks, which means that XRD can be a very powerful fingerprinting process. So what we do is we can get a diffraction pattern with lots of peaks in it, and we can search the positions of those peaks relative to a database that has over 500,000 entries. And we can tell you what's in your sample based on where those peaks are. So it's a very powerful technique in terms of being able to identify something just based on the atoms being lined up in a certain way.